All right, we're going to go over some review of standard form and graphing that standard form. So as you may recall, in standard form, we can easily see the x and the y intercepts. And just a brief review of what the x and the y intercepts are. The x-intercept is going to be when our y value is equal to 0. So that means that the x-intercept is always going to follow the ordered pair of some number, comma, 0. And our y-intercept is going to follow the pattern when x equals 0. So that ordered pair will always follow the pattern of 0, comma, some number. With this standard form, where we have the x's and y's on the left side of our equal sign and the number on the right, we can easily discover these x and y intercepts and very quickly graph it. So if my x-intercept is when y is equal to 0, I simply substitute a 0 in for y. And what that's going to do is that's going to completely cancel out this term because 5 times 0 is 0 and 2x plus 0 is just 2x. So then as I look at my equation of 2x equals 20, I would divide both sides by 2 and I get an x value of 10 because 2 times 10 gives me that true equation of equal to 20. So I'm going to cross my x-axis at a value of 10. Then to find my y-intercept, I'm going to plug 0 in for x. So that essentially makes this term cancel out, being multiplied by 0. And then the y value that satisfies this equation that is left would be 4 because 5 times 4 equals 20. So my y-intercept is at a positive 4. Then I have 2 points on my graph, which is enough to graph the line. So I simply just connect my 2 points, my x and my y-intercept, with my line. Following those same definitions of the x and the y-intercept, to discover the x-intercept, I'm going to substitute in a 0 for y, which cancels out this term, and my x-intercept then would be a value of -1 because 10 times -1 equals -10. So I'm going to intersect my x-axis at a value of -1. My y-intercept would be when x is 0, so I'm going to plug 0 in for x here, which will cancel out this term in my equation. Now I need to make sure I be very careful with my negatives. With this equation that is left, I need to take -5 times a positive 2 in order to keep that value a -10. So I'm crossing the y-axis at positive 2 and then connecting both my x and y intercept with my straight line. These two equations follow a special form where when I have y equals just a number, that means that I need to have every single y value in my equation on my line to be the same and specifically to be at -2. So one example of a point that would have a y value of -2 would be crossing the y-axis at -2. Another point that would have a y value of -2 would be something like this point here of 3, -2. And so this equation is going to create a horizontal line that consistently stays at the y value of -2. In the second graph, when I have x equals a number, that means that every point on my line needs to stay at the same x value. So I'm going to have an x-intercept at +3, and then choose another point that includes an x value of +3, which would be something like 3, 5. And you'll notice now that these 2 points have created a vertical line so that every point along this vertical line has that same consistent x value of +3. We can recall that standard form follows the pattern of ax plus by equals c. Or in simpler terms, our variable terms are on the left side of the equal sign and our number is on the right. So if I would need to rewrite these equations in standard form, I simply need to use inverse operations so that my x and y terms are on the left side of the equal sign and my number is on the right. In question A, the y value is already on the left, so I'm going to keep that there. To move the x value to the left-hand side, I'm going to use inverse operations and add 3x to both sides of my equal sign. Once I've done this, I now have my x term and my y term on the left side of my equal sign and my number on the right, so it is now following standard form. B follows that same pattern. It is in slope-intercept form because y is by itself. So to manipulate that equation so that it's in standard form, I'm going to subtract the x term from the right-hand side. What I do to one side, I must do to the other. And once I do that, I then will have my x and my y term on the left side of my equal sign and my number on the right, which follows that standard form of ax plus by equals c. Parts C and D are both in point slope form, where they have y minus y1 equals m times x minus x1. These equations require a little more work in order to put them in standard form. Before I can use inverse operations, I first must do the distributive property in order to simplify the right-hand side. Then my next step will be to use two inverse operations, because first I need to move my x term to the left side of my equal sign. And then this will also require me one more step in order to move my number 2 to the right-hand side along with the positive 10. After I do that, I will then have my x and my y term on the left side of my equal sign and my number on the right. I'm going to follow this same process to get this last equation in standard form. So first distributing the -4 to the parentheses, then using inverse operations so that my x and y terms are on the left side of my equal sign and my numbers are on the right-hand side of my equal sign. Lastly, we have a story that will have an equation that follows the standard form. At a store, you purchase some t-shirts for $10 and some sweatshirts for $20. You have spent $180 on gifts for your family. We are asked to write an equation to represent this situation in standard form. Since the t-shirts are each $10, we are going to take the number of t-shirts times $10, plus we are also going to purchase sweatshirts. These sweatshirts are $20 each, so we're going to take $20 times the number of sweatshirts, and I have a total of $180 to spend on these gifts, so I'm going to set my expression equal to 180. One note that I'm going to put off to the side are what each of my variables stand for. In this equation, my x values are standing for t-shirts, and my y values are standing for sweatshirts. Writing this note down will help me describe what my x and y intercepts stand for, which is what the second part of the question asks. Once again, the x-intercept is when y is 0. So if I plug in 0 in for my y value, that essentially cancels out my 20y in my equation. So I am then left with 10x equals 180. Solving this using inverse operations leaves me with an x value of 18. So my x-intercept is at the point 18, 0. My y-intercept is when x is 0. So if I plug 0 in for x, that essentially cancels out this first term of 10x and leaves me with the equation 20y equals 180. Then using inverse operations to solve out for that y value gives me a y value of 9. So my y-intercept is following the point 0, 9. The x-intercept represents that I can purchase 18 t-shirts and 0 sweatshirts because the y value stands for sweatshirts and the x value stands for t-shirts for the total of $180 that I have to spend. The y-intercept point tells me that I am able to purchase 0 t-shirts because the x value is 0, and 9 sweatshirts because my y value in this point is corresponding to the number of sweatshirts, once again for a total of $180. So once again, my x value is standing for t-shirts. So in this ordered pair, the 18 is the x value and the 0 is the x value. So in each of those, that is describing how many t-shirts I can purchase. And the Y value is standing for sweatshirts. So in both of my ordered pairs, the Y value will describe to me how many sweatshirts I can purchase for the total of $180.